The idea of a supersonic vertical takeoff jet once sounded like pure science fiction, something that belonged more in movies than in real life. But today, that vision has officially stepped across the line into reality. Tesla has done what many said was impossible. The long-awaited super electric plane, priced at $78,910, has finally arrived. Behind the closed doors of Tesla's research labs and gigafactories, engineers have been perfecting not just a futuristic design, but also a master plan for mass production. And now, in 2026, we are about to witness a rollout so ambitious that it could transform the very meaning of air travel forever. No matter where you live, New York, Los Angeles, London, Sydney, the conversation has shifted. The question is no longer if Tesla will bring aviation into the electric age. The only question is when you and your family will be stepping aboard. So buckle up, because what you're about to hear might change how you think about flying. Tesla's production plan for 2026 is not only bold, it is shocking in its scale and precision. The foundation of this revolution rests on Tesla's global gigafactory network, the same empire that turned the company into an automotive and energy powerhouse. But now the challenge is far bigger. Can those same facilities that pump out millions of cars each year be reimagined to conquer the skies? According to Tesla's strategy, the answer is yes. The production of the Tesla super electric plane officially kicks off in the second quarter of 2026, with 3 heavyweights taking the lead: Gigafactory Texas in Austin, Gigafactory Shanghai in China, and Gigafactory Berlin in Germany. By early 2027, Gigafactory Mexico in Monterrey will join the lineup, adding even more muscle to the operation. Each factory was chosen with clear strategy. Texas has already proven its muscle, delivering over 410,000 vehicles in just 1 quarter of 2025. Shanghai directly connects Tesla to the fast-growing Asia-Pacific aviation market. Berlin is positioned to dominate Europe and the UK, while Mexico brings a vital link for North and Latin America. Together, they form what Tesla calls the global triangle of aviation production. By 2026, each of the 3 leading factories will dedicate about 20% of their floor space to aircraft, retrofitting automotive lines into aerospace-grade facilities. We're talking about composite airframe assembly, aluminum air battery modules, and specialized robotics designed for planes instead of cars. The investment is staggering. Around $500 million per factory will be poured into this transition, adding up to $1.5 billion across the first 3. And with $5 billion already committed to Mexico, the total figure shows just how serious Tesla is about executing. It may sound huge, but remember, Tesla built the Shanghai factory in just 10 months back in 2019. They've proven they can move fast and scale even faster. Vertical integration, Tesla's signature advantage, plays a massive role here. Just as the company already produces about 80% of its car components in-house, that same model will apply to aviation. The result? Lower costs, tighter control, and the ability to scale production at a speed no aerospace company has matched before. And the numbers reflect that ambition. Texas alone is expected to pump out 5,000 planes per year by 2028, which is half of Tesla's total output. Shanghai will deliver 3,000 annually, Berlin another 2,000, and by 2027, Mexico adds 2,000 more. That's a total of 10,000 planes a year by 2028, scaling to a jaw-dropping 20,000 annually by 2030. Put that in perspective. The global light aircraft market is roughly 200,000 units each year. Tesla plans to grab 5% of that entire market within 4 years of launching. And with the electric vertical takeoff and landing sector projected to reach a $9 trillion valuation by 2050, the math couldn't be more favorable. So how is Tesla going to achieve this scale? Automation. Already, 80% of a Model Y's assembly is handled by robots. Translating that into aerospace means Tesla can slash labor costs by 30% compared to legacy giants like Boeing or Cessna. SpaceX's expertise also pours into the equation. Lightweight composites, carbon fiber structures, and FAA certification processes, all refined through years of rocket development, Now streamline Tesla's aviation costs another 20% below industry norms. To keep everything powered, each gigafactory will produce 10 gigawatt-hours of aluminum-air batteries annually, enough for between 5,000 and 10,000 planes. This isn't speculation. It's the same strategy Tesla used to scale its auto production from under 1 million cars in 2021 to nearly 2 million by 2024. They know how to scale. The only question is whether you're ready to see 5,000 planes a year coming out of Texas alone. But production is only half the equation. The real shocker is how Tesla plans to distribute these planes worldwide. Right now, Tesla operates over 200 distribution centers across the globe for its cars, solar products, and charging systems. That same infrastructure will be repurposed for aviation. The moment production begins, Tesla won't be starting from scratch. They'll be plugging into a system that already handles millions of deliveries per year. If they can ship 1.79 million cars in a single year, a few thousand planes are a piece of cake. But the real innovation is in where these planes will be delivered. Tesla isn't relying only on conventional airports. Instead, they're planning 100 urban vertiports by 2028, 50 in the US, 30 in Europe, 15 across Asia, and 5 more across the UK and Australia. These aren't just landing pads, they're charging hubs, maintenance stations, and direct delivery centers planted right inside the cities where people actually live. Imagine ordering your Tesla plane, and instead of driving hours to an airport, you pick it up at your local vertiport in Los Angeles, New York, or London. Delivery timelines make this even more practical. A U.S. customer ordering in the third quarter of 2026 could see their plane delivered in the fourth quarter, just 3 months later. In the UK, it's about 3.5 months. In Europe, around 4 months. Even in Asia, with massive demand, Tesla guarantees delivery within 5 months thanks to Shanghai's capacity. Think about that. A customer in Tokyo could order mid-2026 and be flying their Tesla plane by early 2027. This mirrors Tesla's Model Y ramp-up, which went from zero production to over 1 million per year in 4 years. Backing this rollout is Tesla's $10 billion cash reserve and $13 billion R&D budget, shared with SpaceX, and then there's Starlink, with over 7,000 satellites already in orbit, providing real-time tracking and global connectivity for every Tesla plane. Now let's talk about the real breakthrough, the battery. For decades, electric flight was held back by one insurmountable problem: heavy batteries. Jet fuel delivers about 12.0 watt-hours per kilogram, while traditional lithium-ion batteries only managed about 320. But Tesla's aluminum-air technology changes everything. Achieving 520 watt-hours per kilogram, it slashes aircraft weight by over 3,000 pounds, finally making electric planes not just possible but practical. Here, how it works. Instead of storing all its own oxygen, the aluminum-air battery draws oxygen directly from the air, serving as a natural cathode. This design dramatically reduces weight while boosting efficiency. Lab tests already hit 1,000 watt-hours per kilogram, but the 520 version is certified for aviation use. Combine that with electric motors that run at triple the efficiency of jet engines, and suddenly a 720-mile flight range is achievable. That's New York to Chicago, Los Angeles to Denver, all with zero emissions at a fraction of the cost of fuel. Safety is another game changer. Unlike lithium-ion packs, aluminum-air cells are non-flammable, passing both FAA and European EASA standards. Tesla's advanced battery management system, honed over millions of cars, optimizes charge cycles and extends battery life to about 3,000 cycles, roughly 30 years if you fly 100 times a year. That's unheard of in aviation. The SpaceX connection once again pushes the boundaries. Lightweight carbon composites, perfected in Starship's design, shave 15% off Tesla's airframe weight. AI-driven navigation systems, originally built for rockets, now empower Tesla's self-flying technology, delivering flight precision beyond human pilots. This collaboration creates an edge traditional aerospace manufacturers simply cannot match. Infrastructure is the next piece of the puzzle. Tesla isn't relying on old fuel stations or outdated runways. Instead, they're rolling out a $2 billion plan for electric aviation infrastructure, centered around 200-megawatt charging stations by 2028. The US gets 100 of them, Europe 50, Asia 40, and 10 more in the UK and Australia. These aren't just superchargers. They're megachargers, adapted from Tesla Semi technology, capable of delivering 80% charge in just 30 to 45 minutes. Maintenance is equally revolutionary. By 2028, Tesla will launch 50 global service hubs, strategically located near gigafactories and vertiports. Each one leverages AI-driven diagnostics that cut service costs by 20% compared to traditional aviation. The Texas hub alone will service 2,000 planes annually, offering 24-hour turnaround times that make airline maintenance look primitive. With Starlink, real-time software updates, and remote diagnostics keep uptime at 99.9%, while lessons from reusable rockets bring space-age servicing efficiencies into everyday aviation. This integrated system, production, delivery, charging, maintenance, redefines what air travel looks like. Operating costs drop 80% below traditional jets, making private ownership and commercial use both viable. Imagine a world where flying city to city is not only cleaner but cheaper than driving. That's the world Tesla is building.